On July 25, 2025, a Chinese company walked onto the stage of the World AI Conference in Shanghai and announced something that made robotics engineers around the world stop and reread the press release. A fully functional humanoid robot. 2 legs, 2 arms, capable of walking, running, carrying objects, and processing spoken commands through an onboard AI system. Price? $5,900. That's less than a used car, less than a high-end laptop, less than what most Americans spend on a vacation. The company was Unitree Robotics, based in Hangzhou, China. The robot was called the R1, and in a single product announcement, Unitree did something that the entire Western robotics industry said wouldn't happen for years. It put a humanoid robot within reach of universities, small businesses, developers, and within a few years, ordinary households. Meanwhile, across the Pacific, Elon Musk was on an earnings call telling investors that Tesla's Optimus robot was facing a magnet issue. The rare earth metals needed to power its actuators, the motors that make its joints move, were stuck behind Chinese export controls. His team was working through it with China. A Chinese company was selling humanoid robots for under $6,000. The most hyped robot in America couldn't move its arms because it needed materials that China decided to stop shipping. That contrast tells you everything you need to know about where the humanoid robot race actually stands in 2025. In this video, we break down exactly how China built a $5,900 humanoid robot, why Tesla's Optimus keeps falling behind its own promises, what the rare earth weapon really means for American robotics, and why the winner of this race won't just dominate manufacturing, they'll reshape the global economy for the next 50 years.
To understand why this race matters so much, you have to understand what humanoid robots actually represent, not as a product, but as an economic force. The global labor market is facing a structural crisis. Aging populations in the US, Europe, Japan, and China itself are shrinking the workforce. Manufacturing costs in developed countries are rising. The demand for workers in logistics, warehousing, and assembly is growing faster than the supply of people willing to do those jobs. Humanoid robots are the answer that every government and every major manufacturer on Earth is betting on. Jensen Huang, the CEO of NVIDIA, said robotics has the potential to become a multi-trillion-dollar industry. Elon Musk himself said Optimus could eventually generate $10 trillion in revenue for Tesla. Goldman Sachs projected the humanoid robot market could reach $38 billion by 2035. The race to build a commercially viable humanoid robot isn't just a technology competition. It's a race to own the most valuable manufacturing platform in human history. For most of the last decade, the assumption in Silicon Valley was straightforward. America would win that race. Boston Dynamics had the most physically capable robots on the planet. Tesla had the most advanced AI. Figure, 1X, Aptronic, a generation of well-funded American startups was working on the problem. China was seen as a fast follower, good at manufacturing, good at copying, but not at the bleeding edge of robotics innovation. That assumption is now outdated.
In the first 9 months of 2025, China's robotics sector recorded 610 investment deals, totaling $7 billion, a 250% increase over the same period in 2024. In the third quarter alone, there were 243 deals. Not in Silicon Valley, not in Boston, in China. By the end of 2025, China had shipped roughly 90% of all humanoid robots delivered worldwide. The top humanoid robot makers by units shipped were Agibot and Unitree, followed by Ubitech, Liju Robotics, Engine AI, and Fourier Intelligence. Tesla's production target for 2025 was 5,000 Optimus units. It didn't hit that number. Unitree and Agibot each sold more units than Tesla's entire 2025 production target. China now controls more than 70% of global industrial robot installations overall, a $14.2 billion domestic market that grew 47% year over year, the fastest of any major economy. The fast follower became the leader. and most Americans have no idea it happened. Three forces came together simultaneously to make this possible. The first is supply chain. The Yangtze River Delta, the industrial corridor surrounding Shanghai, hosts what analysts now describe as the world's most vertically integrated humanoid robot supply chain. Unitree manufactures its own motors, reducers, and sensors in-house. Component suppliers, including spin-offs from DJI, EV actuator manufacturers, and precision parts makers, are within a 2-hour logistics radius. When Unitree wanted to cut the price of the R1 to $5,900, they could do it because they controlled the entire production stack.
The second is industrial demand. BYD, the world's largest EV maker. CATL, the dominant battery manufacturer. Foxconn, the factory behind every iPhone. These companies represent demand for tens of thousands of humanoid robot units. And they're not just buying, they're investing directly in robotics companies and deploying robots on their own production lines. China has a built-in customer base at industrial scale that no Western robotics company can match. The third is government coordination. In 2025, China's Ministry of Industry and Information Technology and 5 other ministries jointly issued the Humanoid Robot Action Plan, a government directive targeting 100,000 deployed humanoid robots across Chinese industry by 2027. When the Chinese state decides something is a strategic priority, capital, policy support, and talent follow at a speed and scale that no private sector ecosystem alone can replicate.
To understand why a $5,900 robot is such a breakthrough, you need to understand what makes humanoid robots so hard to build in the first place. The human body is extraordinarily complex. 206 bones, over 600 muscles, and a nervous system capable of making hundreds of micro-adjustments per second to keep us balanced, moving, and interacting with the world. Replicating that in a machine requires solving 3 problems at once: balance, actuation, and intelligence. Balance means the robot needs to stay upright on 2 legs while moving. A 4-legged robot is dramatically easier to stabilize. It always has 3 contact points with the ground. A biped is like an inverted pendulum, inherently unstable, requiring constant real-time correction just to stand still. Actuation means the robot needs joints that move with precision and generate the right amount of force. Not so weak it can't lift anything, not so strong it damages what it's handling. The key component is an actuator, a high-precision electric motor combined with a gearbox. Building actuators that are powerful, precise, lightweight, and affordable is one of the central engineering challenges of the field. Intelligence means the robot needs to perceive its environment through cameras and sensors, process that information, and decide what to do in real time. Until recently, robot AI was rigid and pre-programmed. The integration of large language models and vision language action models, giving robots the ability to understand spoken instructions and visual context, is the breakthrough that's making general-purpose humanoids possible.
Now, here's what Unitree built. The R1 is 25 kilograms, roughly the height of a teenager. It uses a multimodal large language model integrating speech and image recognition, meaning it can receive verbal instructions and use cameras to understand its environment. Its actuators are built in-house, a detail we'll come back to. The R1 isn't Unitree's most capable robot. It's their most affordable. Think of it as a platform for developers and researchers, an entry-level product designed to get hardware into as many hands as possible and let the software ecosystem grow around it. Unitree's flagship full-size humanoid is the H1, 180 centimeters tall, 47 kilograms, world record locomotion speed. At the World Humanoid Robot Games in Beijing in August 2025, the H1 won gold in a 1,500-meter race with a time of 6 minutes and 35 seconds, beating the average mile time on Strava by close to 4 minutes. A robot running a mile faster than most humans. Then there's the H2, the next generation model, at $29,900, with 7 degree of freedom arms, the full range of motion needed for complex manipulation tasks like assembly, packaging, and maintenance.
Unitree's lineup: R1 at $5,900, G1 at $16,000, H2 at $29,900, H1 at $99,900, covers every market segment from student developers to industrial manufacturers.
No American company has anything close to this range. The reason Chinese humanoid robots can hit these price points isn't just cheap labor. It's vertical integration combined with spillover from the EV industry. China's electric vehicle boom created a massive domestic industry for electric motors, battery systems, and precision actuators. The same engineering expertise and manufacturing capacity that went into building 10 million EVs per year is now being redirected into humanoid robots. Companies like BYD are investing directly in robotics because their existing supply chains already produce the core components. Unitree doesn't buy its actuators from a supplier and pay a markup. It designs and manufactures them in-house, in the same industrial corridor where its entire supply chain lives. That cost reduction is the difference between a $5,900 robot and a $50,000 robot. Now let's look at where Tesla's Optimus actually stands, honestly.
Tesla has been developing Optimus for over 5 years. The robot is real. It exists, it moves, it can perform tasks in controlled environments. In demos, Optimus has folded laundry, sorted objects, and walked with reasonable fluidity. But as of the end of 2025, Tesla's production was in the hundreds of units, not the thousands it projected. Elon Musk acknowledged on the Q4 2025 earnings call that Optimus robots weren't yet doing useful work. Independent reporting described unresolved hardware challenges requiring design changes. The company's public timeline has shifted repeatedly. And then came the magnet problem. In April 2025, China's Ministry of Commerce restricted exports of 7 rare earth elements, including dysprosium and terbium, materials essential for producing the high-performance magnets that power Optimus's actuators. The restriction was a direct response to US tariffs imposed by the Trump administration. China produces 61% of the world's rare earth elements and processes 92% of them globally. There is no realistic short-term alternative. When China turned off that tap, Tesla's supply chain for Optimus froze. Musk addressed it on an earnings call. We're working through that with China. Hopefully we'll get a license to use the rare earth magnets. The CEO of the world's most valuable automaker publicly asking China for permission to build his own robot. That sentence alone tells you more about the balance of power in this race than any analyst report. Meanwhile, Unitree sources its rare earth magnets domestically with zero exposure to export restrictions. The one area where American companies genuinely lead is AI software for robotics, the brain that tells the body what to do. Companies like Physical Intelligence in San Francisco have developed foundation models for robot behavior that are ahead of anything China has publicly demonstrated. But that gap is closing. China's robotics companies are integrating DeepSeek-based models and domestic vision language action systems into their platforms. And a robot with 80% of the AI capability at 20% of the price tends to win in the commercial market, especially when the buyer is a factory manager looking at total cost of ownership.
The humanoid robot race isn't just a competition between companies. It's a competition between 2 models of industrial organization, and the outcome will determine who controls the next wave of global manufacturing. China's decision to restrict rare earth exports in April 2025 was surgical and deliberate. It didn't target all industries. It targeted the specific materials needed for high-performance magnets, the components at the heart of every advanced electric motor and humanoid robots, EVs, wind turbines, and military hardware. China controls 61% of rare earth production and 92% of global processing. There is no mine you can open, no factory you can build that replaces that capacity in less than a decade. The United States has rare earth deposits, but almost no processing infrastructure. Australia has deposits, but sends most of its ore to China for processing. When Tesla stock fell 20% in the first quarter of 2025, Chinese robotics companies and rare earth producers saw their stock prices jump. The market understood the strategic logic immediately. China had found a pressure point, and it used it with precision. Now, here's what 90% market share actually means at a deeper level.
Every robot that ships is a data point. Robots in the field generate operational data: how they move, how they fail, how workers interact with them, what tasks they can and can't complete. That data feeds back into AI training, which improves the next generation of robots. China is generating that data at a scale that no other country comes close to. Its domestic manufacturing base is deploying robots in real industrial environments and feeding real-world performance back to Unitree, Agibot, and dozens of other companies. American companies are mostly still in the demo phase. Chinese companies are in the deployment phase. And in technology, deployment generates the data that wins. Unitree CEO Wang Xingxing has said publicly that humanoid robotics will reach its iPhone moment within 3 to 5 years, the point where the technology becomes reliable enough, affordable enough, and useful enough to trigger mass adoption. That parallel deserves to be taken seriously. Before the iPhone, smartphones existed, but they were expensive, clunky, and hard to use. The iPhone didn't invent the smartphone. It made it accessible. China's smartphone supply chain is already pivoting to humanoid robot production. Lingy iTech, a Foxconn supplier that assembles iPhone components, has publicly targeted 500,000 humanoid robot units annually by 2030. The most efficient consumer electronics manufacturing ecosystem ever built is being retooled to produce robots at volume, at price points that will keep dropping.
Morgan Stanley doubled its delivery forecast for the Chinese humanoid market in early 2026, projecting 28,000 units in 2026 alone, a 133% increase over 2025. Now, here's the consequence that almost no one is talking about honestly. Humanoid robots, at scale, will replace a significant portion of the global manufacturing workforce. Not immediately, not all at once, but over the next 20 years, the factories that employ millions of workers in Southeast Asia, Mexico, Eastern Europe, and the American Midwest will increasingly run on robots. The country that manufactures those robots captures the economic value of that transition. Every robot deployed in a Vietnamese factory, a Mexican auto plant, or a German warehouse represents a revenue stream for the company that built it, the country that built the supply chain behind it, and the government that made it a strategic priority. If China ships 90% of the world's humanoid robots at market scale, China captures the majority of the economic value generated by the automation of global manufacturing. That is not a science fiction scenario. It's the trajectory the data from 2025 already points toward. Elon Musk acknowledged it directly at the World Economic Forum. China is very good at AI, very good at manufacturing, and will definitely be the toughest competition for Tesla. To the best of our knowledge, we don't see any significant competitors outside of China. The CEO of the company that's supposed to win this race is publicly saying China is his only serious competition. To be fair, the picture isn't entirely one-sided. Morgan Stanley surveyed companies expected to buy Chinese humanoid robots in 2025. Only 23% said they were satisfied with the products available. Battery life tops out at 2 to 3 hours per charge. Most deployments are still in showrooms and exhibitions, not full-scale industrial operations. China has more than 150 humanoid robot companies competing for the same market. That level of competition will produce consolidation, failed companies, and wasted capital. The race is real. It's not over, but the starting position has fundamentally shifted. On July 25, 2025, a Chinese company sold a humanoid robot for $5,900. On the same day, the leading American humanoid robot was stuck waiting for a license to import magnets from the same country that just undercut its price by a factor of 5. China didn't build this lead by accident. It built it by doing what it has done in every strategic technology of the last 2 decades. Identify the target, build the supply chain, deploy at industrial scale, and cut the price until no competitor can follow. It happened with solar panels. It happened with batteries. It happened with electric vehicles. China now produces 80% of the world's solar panels, dominates EV battery manufacturing, and has the world's best-selling EV brand. Humanoid robots are next on that list. The United States still has real advantages.
in AI software, in research institutions, in private capital. Those advantages matter, but they're being competed away faster than most people realize by a country with 610 investment deals, a government action plan, a fully integrated supply chain, and a robot that sells for less than a used car.
The question isn't whether humanoid robots will reshape global manufacturing. They will. The question is who builds them, who sells them, and who captures the economic value when 1 billion factory jobs get automated over the next 30 years. The answer to that question is being written right now, in Hangzhou, in Shanghai, in the Yangtze River Delta, while the rest of the world is still arguing about the timeline. Subscribe to World Shift and turn on notifications. Every week, we bring you the stories that the mainstream conversation hasn't caught up with yet. The mega projects, the power shifts, the technologies quietly building the world your children will live in. Understanding what's coming starts today. We'll see you in the next one.